So what we're going to do here is with this equation, we're going to say, I don't know what kind of arrow I need here, right? Is it a go all the way to completion arrow? Is it an equilibrium arrow? Or is it a, oops, I don't go forward arrow? Okay, so let's decide what we think. So I'm just going to draw like a little line separating my reactants from my products. Maximum entropy. What is entropy? Entropy is randomness or disorder. And if we have maximum randomness, which side is more random? The reactants or the products? Tell your partner. Page 115. And if you have your phone, you need to get off your phone. Page 115. Which side is more random? We have a solid, aqueous, versus aqueous, gas. Which side is more random? Aqueous gas, yes. So if this is more random, maximum entropy favors the products. Yes? So what that means is we have one arrow which is saying, go forward, please. Yes? Minimum enthalpy. Which side does minimum enthalpy favor? In other words, which side has the minimum enthalpy? Products has, it has the heat term. So we have lower potential energy. So minimum enthalpy favors the products. So what that is that that arrow is also pushing the reaction forward. Yes? So we have two factors pushing the reaction in the forward direction. Which of these three arrows is it going to be? Number 1, number 2, or number 3? Number 1, because everything is pushing it that away. So would we say this is spontaneous or would we say it's non-spontaneous? This would be spontaneous. Would we say the reaction, does it go to completion, not proceed, or form an equilibrium? It goes to completion. And draw in the correct arrow symbol. We already did that. And what is the value of KEQ like? Now, I don't know if you guys read that yesterday. Did you read that yesterday? Okay, so if we have going to completion, what's the KEQ going to be like? KEQ is greater than 1 because it favors the products. Now, what if we had a no-go situation? KEQ would be not too small. It would just be small. Smaller than 1. Smaller than 1. So it favors the reactants. Yes? And if it forms in an equilibrium, KEQ is going to be approximately equal to 1. Now, when I say that, I'm kind of lying to you because these things all are, so, I mean, there's not a whole lot of equilibriums where they actually equal 1. Okay. Anyway, you can say KEQ is large. KEQ is small. And for this one, KEQ is close to 1. Is good? Okay. Now, to be fair, we're going to find a lot of KEQs that aren't close to 1 at all. We're going to have KEQs that are, 10 to the negative 16, and we'll still work with them, okay? And we'll still work with the part that it will still form an equilibrium, but it's a equilibrium that, say, heavily favors the reactants or heavily favors the products, okay? All right, do you guys think you could do number 2 by yourself? Can you try it? Or do you want to do it together? One more together? One more together. Okay. So maximum entropy. What do you look at when you're trying to decide entropy? You look at the states. Well, we have a gas and a gas and a gas. Uh-oh, they're all gas. What do I do if everything's a gas? I have to look for the number of gas molecules. More gas molecules is more random. Okay, so that means that maximum entropy is over here. So which way is entropy pushing the equilibrium? Is it pushing it to the products or is it pushing it to the reactants? It's pushing it to the reactants, okay? So there we go. Minimum enthalpy. Which side is always favored by minimum enthalpy? The side with the heat term. Okay, here's our heat term. So here we have minimum enthalpy. Which way is minimum enthalpy pushing? It's pushing to the reactants once again. What are our 3 choices of arrow? Either forward or equilibrium or no-go. Okay, because we're assuming we're going to start with A and B. What kind of an arrow are we going to have here? The last one. So this is a no-go. So is this process spontaneous or non-spontaneous? Non-spontaneous. And the reaction will go to completion, not proceed, or form an equilibrium. Not proceed. And what will the value of KEQ be like? KEQ will be small. Okay? Can you do the third one? Yes. Try it. Try it. Try it. That's okay. If you get it wrong, then you learn something, right? How do I tell if it's spontaneous or not? Spontaneous? Spontaneous? Yep. Non-spontaneous. You say, if my maximum entropy is over here and my minimum enthalpy is over here, then both arrows are pushing this way, and that means it's a no-go. Yes? So if they're both going reactants, then it's a no-go. If they are both pushing to the right, then I'm going to get spontaneous and goes to completion. So basically you're looking for which side is favored. If they both favor reactants, it's a no-go. If they both favor products, it's go to completion. If one favors one and one favors the other, it's going to form an equilibrium, okay? Like I said, this is a really oversimplified version. You can actually do math around it and say how much is it going to favor the products and how much is it going to favor the reactants, but we don't do that in Chem 12. We'll leave that for first year university. Okay, which side does maximum entropy favor, products or reactants? Products, because we have two gases. So we got one arrow pointing that way. More random. Minimum enthalpy favors the reactants. So minimum enthalpy is saying go this way. So if we have entropy, Caitlin, you were asking questions about this. Should you be playing with cards right now? No. Okay. You understand it now? So what kind of arrow should we have? Equilibrium. Good. And it is spontaneous. And what is our value of KEQ like? Close to 1. Now that might be 10,000. 10,000 is kind of close to 1 when you compare it with, a billion, right? So we're not worried. When we're doing this, we're not worried about actual numbers. So you can just be like close to 1, whatever that means. All right. So at this point, I have taught you, I believe, everything you need for equilibrium except for one thing, which you were asking about today. And that is, if I was to give you A plus 2B in equilibrium with C, and I said the KEQ is 1.3 times 10 to the negative 5. This is just nothing. This is nowhere. You need to write it down somewhere. It's a little standalone. Find a piece of paper, find your inside back cover, whatever. Let's say these are all gases just to make it life nice. I want to see if any of you can figure it out on your own without me telling you. 1.3 times 10 to the negative 5. What? Huh? You're kind of on a right-ish track. You're thinking about it. Try writing the KEQ expression for each of these. Tell your partner if you've got it figured out, or if you think you've got it figured out. What's the correct answer? Oops, hang on. I'm rounding wrong. Did you guys get that? How did I get that? Yes, because this, if we take it and flip it over, yes, this is the reciprocal. Yes, so what we do then is we say, let's call this KQ prime, okay? It would be equal to 1 over the KEQ for the reverse reaction. Yes? Oh, it probably is 4. I think it is 4. I just can't, like, count. Yeah, you're right. It's 4. Okay, so that's the last thing I need to teach you. Theoretically, I've taught you everything. Now, one thing I do want to mention from the quizzes is that if it doesn't say, if I got an equilibrium and it said I placed some C and some B in a container, how much A did I place in the container? How much A did I place in the container? I put some C in the container. I put some B in the container. How much A did I put in the container? It's not a trick question. It's the question that everybody got wrong on the quiz, or lots of people did. If I don't say I put any in, then I didn't put any in. If I say I put some C in, that means there's C. If I put some B in, there's some B. If I don't mention A, I did not put it in. There is none. Okay? If it's not mentioned, we haven't put it in the container. How does it work? You're going to have to shift in the direction of A. You're going to have to shift that way because, yeah, then we have to shift towards A if there's no A. Huh? C breaks down. Or, yeah, into A and B. Yeah. I get it now. Yeah. C breaks down into A and two particles, one A and two particles B. I get it. Yeah. Yeah. No, it's okay. That's why we do all these things, right? Because sometimes we see things the first time and we're like, that makes no sense. So make sure if you have questions today on the quiz that you ask. You should probably do some practice on the entropy and enthalpy. So that would be like pages 117, 18, and 19. Well, really 117 to 120 if you want. Okay. But you should also be working on the overall review. So if you have not yet received the overall review, I will grab those and put them out so you can get yourself one. So if you've been absent and you would like to grab yourself one of these, that's the review, that's the answer key. Tomorrow will be a review class. You're going to absolutely ace this test, right? I want to see a brain break first. It's called school, and then I'm going to play. I mean, not because sometimes won't be like this game's under, but I'll be right on it. Oh, after my okay. Bye, do nice thing. Hi.
So here, I get that it's positive, but because I know we are going to be is positive because we are going towards the reactants, but then we have 6 molecules here and 7.5 molecules here. So we would have more randomness this side.
Yes.
So why the S is not?
Oh, is the answer key wrong?
No.
You have 7.5, 8.5. This side you have 9. 6 plus 3 is 9.
That's liquid.
Oh, that's a liquid. Oh, maybe I read the question wrong when I was answering it. Probably. I'm guessing that's what happened. So I'm probably wrong.
It's not positive?
No, I think it should be negative. I think you're correct. I think I thought that was a gas when I was answering it. Yeah. What page is that so I can write it down and make the change?
114.
114.
No, 114. No, for me it's 1 page more, so it's 113.
Oh.
Yeah, 113.
Okay, you got a special copy. Oh my God, how have you been dealing with that?
I love it.
Okay, good.
Just negative.
Okay, negative. All right, thank you, thank you. Hi. Yes. Where is it? Oh, there we go. There you go. Hello. Yes.
Why this one is
because you didn't actually answer the question. It says, what is the concentration of CO? Did you anywhere say the concentration of CO is?
specific?
I know. I know.
And here,
Well, that's not 0.64.
0.44?
Yeah, because if you do the subtraction, it's not
Huh,
0.64. That's
that was
just an
also
adding
wrong.
error. That's just a silly, right?
Great,
Yeah,
great.
yeah,
Thank you.
yeah, no problem. Hi.
Can you help me with this?
Yes. Okay. Which of the following circumstances may endothermic reaction take place spontaneously? So we do not want to have, like, enthalpy is not pushing it forward. So we need entropy to be pushing it forward. So we need entropy to be pushing this way. So what should be happening to the entropy for that, the forward process to be favored? Do you want entropy to increase or decrease?
So the randomness has to be increased.
Yes,
How do we know?
because it says the system's entropy is sufficiently increased.
Oh.
Like
Oh,
that,
yeah.
yeah,
Makes sense.
yeah.
Oh, what else?
Uh-huh,
This point here.
yeah.
Those are the same answer, doesn't it? Because
Uh,
the calculator it says
oh. 1 divided by 25 equals, oh, it is. Okay, so number 97 has a problem. Okay.
yes.
Number 97, multiple choice, equilibrium, review. Two answers are the same. Okay, thank you. Thank you. Bye, Timon. Yes. Hi. Why did you erase it? It's just, the rice table is really there to say this is how I'm setting up the problem, and now I'm gonna do it. Yeah. Yeah. No, that's not what it's used for. Yeah. Yeah. I'm happy to do another copy. Hi, I'll just be 1 second. I gotta write something down before I forget it. And where would I have put that book? I might have put it in here. I did. How clever of me. Okay. Yes. Yeah. Do you want to go in a little bathroom? Yeah. Cool. So. Yeah. So if you want to, for example, start by saying, I'm going to go to the example, I'm going to do this, and see if I can first also that word here. And all these are How those go. I know what you mean. You're technically right. Yeah. Oh, you guys know that Hebden has an answer key in the back, right? Okay. Yeah. So. Yeah. You have yours? Oh, okay. All right. Remember, enthalpy, you think of it as being potential. And temperature is kinetic. Yeah. But it's the change in enthalpy. It's not the enthalpy in the chemicals. It's the change in enthalpy in the transformed into essentially. So that's why the organism really picked up the really function just transfer that. So enthalpy is change in enthalpy is a system. It doesn't highlight. So these anything you want to outlet, increase temperature, yeah. All the things that change it. Okay. So what you can use is like I'm like that we have three. So we have F and three. Which you will dissociate into FG, 3 plus, 3 minus, and then we have AFCN, which will dissociate into 3 plus, that's 3 minus. Okay, this is a spectator. This is a if I wanted to write out the whole thing, I could write it out first. Those two. And you don't have to worry about how that form gets written. Yeah. Wait, no, I was wrong. Wait, no. Okay, and then you would have what's left over potatoes. All of it is yeah, and then you would have to say. So the one let's just not even worry about balance. This one's okay. So, except for really what I said is that F is three. Right? So that F is us. Yeah, yeah. Okay. Plus. Big plus, sorry. Big plus. Ah. So, we're looking at this on both sides. Yeah. This is on both sides, so we have actually 3 plus. Now, we add some epi, so we're adding more epi, right? So we're adding epi 3 plus. So this is one out. Yes. I would just I would just use this one, it's easier, right? It's just kind of like blocks it out for you so you can see that it's. No, the M3 is irrelevant. Yeah, yeah. Okay, yeah.
Yeah, I know.
Okay, cool.
Yeah.
Yes. Did I have a name? Okay, so, for entropy, so here I have 4 gases and 1 gas.
Yeah.
Here I have 2 gases and 2
Yeah.
gas. Oh, that's. I'm not feeling. H is what random is really is right? Yeah, so I'm gonna go on to that. So let's just omit this one. Yes. There we go. And that's on sheet 117.
Yeah. All right.
Yeah. So you can use it here, but you're correct.
Okay. Well,
Okay, yeah. How are we doing? Anyone got questions? Yes. Uh-huh. Nothing. Nothing. Not a single thing. Nope. You just have more particles that are able to get over that hill. So the hill stays the same size, but the particles are moving faster. So more of them get over the hill. When what happens? Kinetic energy increases. Temperature is a measure. It is a measure of kinetic energy. Because this tells you how much energy is stored in the chemicals. Okay. Yeah. It just means you transform some of this potential into less potential. So kind of the kinetic energy. But if you're increasing temperature, you're bringing in heat from the outside. So you're putting a flame underneath it. That's not coming from the reaction. Okay, it's coming from conflict or whatever. Yeah. Yeah. Okay, so what's the following statement can see for products or favors? You know what it means to say products or favors? It means there are lots of products. Lots of products not included. What that means is there's lots of products that you want to not as much. Yeah. Yeah. Sometimes the language is weird, right? Yeah. So that's why I like to go through questions because that way you'll see all the different sort of words that you have and stuff. Yeah. You're welcome. I'm like technically yeah. I go look at it. Oh, you were just I said, this is KDP for this reaction. I want to do that one. Oh, yeah. Reciprocals are reciprocals, right? If you take the reciprocal of 4, it's 1 over 4. If you take the reciprocal of 1 over 4, it's 4. Yeah. 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 Yeah.
We're close to each other, so one thing. Does it like every school?
Any other questions? No, I'm sorry, don't apologize. This is what I'm here for. Yes, so you need something, so you can't do anything to this. You can't increase this because it's a solid. So that means you can increase one. So we need to add one unit that will cause a decrease in one place. Yes. Beautiful. Yeah.
So concerned
Because it's because it's being built as a therefore don't us. Oh, sorry. Are more random, you can find lower and higher. Yeah. You can start with higher and see. Anyone have questions? No. But you can with your
Wait a minute. Oh, wait.
Yeah. Okay. So you know this one was, this was a mess, and when we add that, and what we'll do is that, because this is always add. Yeah. It's when there's $4. Yeah. So,
I don't have the
so if I have like choose this,
going to.
understood it as I'm adding it.
I don't really do it shorts but this time I'm going to bring water. So I just
Now, when I do that, I get FA, FC, and
and like this other girl in the washroom.
I don't need to know how that was going to be full. The next thing is going to go somewhere. Like family.
Yeah, I tried because words, like if you're right on the border, it's easier to like
In reality,
directly on the
really bad is something that's stay
there. Better. I'll just like watch it. I just thought one of the Where's grade?
Okay. So what we're doing is we're saying I'm adding some 10 plus and I look for them.
to a solution of maybe more of a K because it's a spectator has. So basically, I'm saying like some of this and some of this into a container. What's gonna happen? Yeah. No. So here's the deal. If you take this, okay, we add some energy. Now, remember, in reality, that's three associates in fact. I'm going balancing. But we're going to eventually get efficacy on plus. You don't need to know that how you got that. Yeah. All right. And then what are we left with? Phase. Somebody can okay, so I was solving how they can have that. So we just first plus alpha line.
No, then this was subtracted by that. So
Those two ion together. And so I do the X.
yeah.
Two plus. Wait, no, this one is soluble. Okay, so now all we're left with is yes. So really what we're saying is if I'm adding FEN3, I can ignore the NO3 because it's a spectator. So really what I'm doing is I'm putting X3 plus into a solution with, I can ignore it because it's a spectator and STN minus. So I'm putting in some of this, and some of this, some of it, some. And say, what happens now? Some of this and some of this, and how much of that did I start with? Zero. What's going to happen to you as time goes on? Yeah. Oh, don't worry, they're not all going to be like that. That would be that one question that's like a discerning question. Like, we really know what's going on. You know, it's like for, you know, the student who's like, you know, I want to decide who's getting 100%. Okay. Oh. Hi, did you finish excellent? That, yes. Yeah. Yeah. Absolutely good. Yes.
Oh, it's because that's all the same.
That's right. Not going on. You're like, why am I getting it once? That's impossible because I'm trying to put excess. Yeah. I don't get it. Okay. Two coloring systems will like most fully to completion. We talked about that today. Is that? Yes. Now, when it goes to completion, which direction is favored, forward or reverse? Forward. So what do you think the most of? Products. So what should your pain value be like? Big. Big. There we go. Just the biggest. Oh, thank you. No problem. That's okay. Right? Why do we go things? Very visual. That's very much. How do you get from somebody there? I ran. Just to get out. No, I had also get about that. Really? Yeah. Yeah, I forgot. I didn't even. So it is hard to this. So we have, if we increase the temperature, so our. If we increase the temperature, this will.
No, I don't know, I was walking to school, that's what I saw.
Right, which makes more. Products.
It was for me.
Oh. Are you looking at like nothing? Yeah, okay, so what's happening is essentially the reactants of products. That's when the energy is completely lost. Yeah. That's not possible.
I was not on a roll.
Okay, let's think of this one. Energy, another, joules are unit of energy, so power. Okay, so that
Oh,
means
I swear I don't.
it's got 600. I'm actually scared. It's going to have more or less power rates. I guess the power is also. It's going to be just the same, right? Which means that it doesn't matter if it's moving faster, then it will still have the same potential as the lines are still. Yeah. So you. There is no way that she don't give. Yeah. Okay, cool. Yeah, I've got you. Well, okay. Flashlight. Tomorrow is a study one. Yes. Okay, so change means either it's increasing or it's decreasing. So it's going up or it's going down. So you're going from less to more or more to
Also,
less.
compare like.
Yes. And it turns out that this type of value is cross.
Okay,
Okay?
so I just compare like.
Yeah. This is more random. Also, we got random, so it's like smaller, bigger. Yeah.
Okay. Side with the. That's just. Yeah.
Making a hall pass. We've been told that students are not supposed to leave the classroom. People are like all wandering away and have not asked to leave the classroom. Yeah. So I'm making a hall pass. Making a hall pass. Yeah. Because look, I got this one here, and this one here, and this one here, and they just wandered away. They've not said anything. They've been gone for like 15 minutes. Well, it's about the fact that there's people are wandering around the school and it's irritating people. That's like they're disrupting other classes. They're obviously not doing their chemistry work, right? Yeah. Yes. Yeah, so have running words for that. Okay. We've got 5 particles on one side and 1 particle on the other side. Let's make it a really big thing. It's not just 7, 6, 9, 6. Okay. 5 particles. Squish it. What is the line? Stand Oh. Yes. So it's in, start to go on the fall and over down. Down again. Okay. Yes. It won't be faster, it will be more random.
Oh,
Yeah.
more random.
Yeah.
Okay, so it's like, so deep voices will be more random than the
Yes. Okay. Yeah.
right?
We did like that. All the house. Right. Yes.
Echo. I feel like saying echo would be good. It's just that within the day.
Great, good.
What is the value?
Oh, I should do it.
Thank you. I know. Why do you think? It's like, what is it? But when she wrote the file, it's like, okay, I feel like, what? Okay, I did it.
I know it's universal, but it's like, like convention, we always say. Yeah, and that's so So for this one, did find it open. And it tries to equal that. And like guys who are going to I think
Okay, that person not.
Hi. So, we have orders come on high. We ask it. And I'm cold pass now, look. Right? But it's too small, I mean. You know, something like that. I'll fix it. It'll be done by tomorrow. Most products. Because these are 11 courses. Yes. Okay, so, oh, yeah.
You're so many particular sports. But that must be like posture that and like snow. Or you just like like you're women get them yourself. Okay. Great. That's all I get it. You definitely he's good at something. Okay. Okay, real.
Yeah. 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 Why not? So. Okay. How long
하는 같이 하자.
That's why you think that I want to go. Oh, that's one question. Yeah.
Moving random things.
I'm still mad at her. I don't care. I don't care.
I'm like, why is the zero running fractions? I get frustrating. 12. So like concentration. Things like that. Your knowledge is yeah. Anyway, that's for now. I want to and so my read it. Oh, so Aaron, I'm just gonna think about it tomorrow. You think about it tomorrow. See what you want to do. Like I don't know. I'm just gonna look at options.
Okay, and I think I have your other quiz.
Yeah.
There you go. And I need to find the quiz that you're writing.
So good. Okay.
Hi. Okay.
You're gonna be here tomorrow.
Yes, I
Okay,
am.
I will celebrate.
Yes. Hall pass. Be back in a flash. Don't pee on it. No, my other class is really bad. I've got like 3 people who just like wandered away for 15 minutes. And we're supposed to be cracking down on that, so I'm like, right? Yeah, so I thought maybe it would be helpful to have a cute little hall pass that if you want to go to the bathroom, you have to take a hall pass and ask me. We'll just, take it with you. Well, all these policies you have to have because quite frankly, I don't worry about this class. My other class. And not even most of the other classes, just like 3 people. Yes.
Every break I always try to take up none of the stalls are
Is that during break? During break time? You bring me in, I'll talk to them.
Oh, like in grade 9.
Because the girls' washroom is okay to do that because they're stalls, right? No. Yeah. But the thing is,
And they put it in popular.
Oh yeah.
all right, we have quizzes to give back to you.
Oh my god.
Okay.
I forgot to take out the liquid.
That's okay, it's only half a mark. All right, listen for your name. Dorsa. Laura. Brooklyn. Virginia. Shauna. Hannah. Jessica.
I know.
Isaiah, Grace, Ellie.
Thank you.
No Grace? Okay, I'll call her later. Aaron, Ryan, Juwan, you. Yeah, sorry. Sorry. Hiya, Jiwon. Yeah. Michelle. Jonathan. Daniel. No Daniel? Jody. Samira. Kylie. Samira. Minnie. There we go. Sarah, I haven't marked yours yet.
Oh my God.